Make sure you have this formula. For the probability of A and B, it's the probability of A times the probability of B. A coin is tossed and a six-sided die is rolled. Find the probability of landing on the head side of the coin and rolling a 3 on the die. Use your calculator to multiply. A card is chosen at random from a deck of 52 cards. It is then replaced and a second card is chosen. What is the probability of choosing a jack and then choosing an 8? Keep in mind that once we choose the first card that we do replace it back into the deck. Use your calculator to simplify. A jar contains 3 red, 5 green, 2 blue, and 6 yellow marbles. A marble is chosen at random from the jar. After replacing it, a second marble is chosen. What is the probability of choosing a green and a yellow marble? Again, we choose a marble, what's the probability of green? We put the marble back, and then what's the probability of yellow? Use your calculator to multiply. A school survey found that 9 out of 10 students like pizza. If 3 students are chosen at random with replacement, what is the probability that all 3 students like pizza? So this is the probability of a randomly selected person likes it. Put that person back into the mix and randomly select again and again. Dependent events are the occurring effects the probability of B occurring. Usually you'll see the words without replacement. So we'll take the probability of A and multiply it times the probability of B given whatever happened to event A. This time when we choose the green and then the yellow, we keep the first marble. What will change in our problem when we keep the first marble? It's going to affect your denominator. If you keep one of those marbles, it will decrease your denominator by 1. An aquarium contains 6 male goldfish and 4 female goldfish. You randomly select a fish from the tank. You do not put it back into the tank, you keep it. Then you randomly select a second fish. What's the probability that both fish are males? When we go to pick the first fish, there are 6 total. But when we go to pick another one, there's 1 less male and there's 1 less fish in the tank. So this time we're going to decrease the top number and the bottom number. This only happens when you pick the same object back to back. A random sample of parts coming off a machine is done by an inspector. He found that 5 out of 100 parts are bad on average. If he were to do a new sample, what is the probability that he picks a bad part, another bad part, if he doesn't replace the first? When you pick the same thing back to back, you decrease your numerator and your denominator. Determining if 2 events are independent. There are 3 ways to check. We're only going to use one of the ways. We're going to practice using your formula by substituting in the information and see if left side equals right side. Use your calculator and see if 0.6 times 0.5 equals the left side. Your conclusion. When these 2 sides are equal, we've proven that they are independent.